Burning fat, it ain't rocket science. Or maybe it is. Because in this video, I'm going to break down a very simple, easy to follow technique that was actually inspired by NASA scientists to help you burn fat fast. So I've had a lot of people say, I feel like I'm not eating anything and I lose some weight, and then I just stop losing weight. Should I just eat less calories? And the short answer is no, because that approach doesn't work. And it's all right. You know, I've done that too, where I'm like, oh, I'm just going to not eat anything and I'm going to work out a lot. High expenditure, low intake of food. That's the recipe for burning some fat. At least that's what I thought. And recently I had remembered a time when I was a little kid at space camp. Yeah, I did the space camp thing as a kid, and I remembered this story that they told us. So the story goes that NASA scientists, they're like trying their hardest to make a rocket to go to the moon. And when they're doing the designs and they're crunching the numbers, they're like, guys, we got a problem. And they're like, what's the problem? They're like, so we need this amount of fuel to get to the moon. They're like, all right, we'll just put that much fuel in the rocket. And they're like, but here's the tricky part. If we put all that fuel in the rocket, it's going to weigh too much. The rocket's heavier, then we need more fuel. They're like, all right, well, we'll just put more fuel in. And they're like, no, but that's the issue. The more fuel we put in the rocket, the more fuel it needs to get to the moon. But the more fuel we put in, the heavier it gets, and that's the problem. They're like, holy crap, how do we do this? And I'll say how they solved it in a second. But that story, you know, we find that like if we're trying to get to the moon, so to speak, by hitting our goals, we think like, all right, I just got to cut out a big chunk of calories and problem solved. But oftentimes what happens is our body adapts to that very quick decrease in calories. And with such a steep decrease in calories, what happens to the body is it says, oh crap, we got to slow down our metabolic processes because we're not getting enough energy in. So if we're burning more energy just to stay alive than we're getting in, that's not good for staying alive. You know, think of the body in the wild, like caveman times. It's like if they're not getting their food for a while or they're getting little bits of food, their body's going to be like, all right, this caveman's having an issue getting some food. Let's just slow down the metabolic processes because we don't want this guy to die of starvation. And that's what the body does when you drastically cut your calories like that. So the solution is what the scientists at NASA did. What they discovered was what they were like, what we're trying to do is we're trying to put all the fuel in one big ass canister on this rocket. And when we light that canister and it's sending that rocket to the moon, as the canister is losing that energy, the weight of the canister is staying the same. So they're like, we don't even need all that fuel to be in one canister the whole time. Let's put a big chunk of fuel in a section of a canister, and when the rocket goes, we need a lot of fuel to get it off the ground, and then once it builds up that momentum, we don't need as much fuel. So they shoot off the canister, and then the second thrusters kick in, and then it starts to go, and then as it starts breaking past the atmosphere, less and less gravity is pulling the rocket down, so less fuel is needed to propel it upwards, and these canisters will break off into sections, and each time a section is removed, the rocket weighs less, so it needs less fuel. The higher up it goes, the less fuel it needs as well. And then eventually, when it's in space, like I don't know if you've seen in those videos where they have like the little air that spits out on the sides. That's quite literally what it is. It's just compressed air. And the reason why they don't need to use fuel or gas is because A, compressed air is weightless. It's air. And B, the amount of propulsion from just a little puff and then just keeps going indefinitely because there's no friction, there's no air, there's no gravity or anything like that. So that's how they solved it. They're like, we're going to break this off in sections. And the same thing is true with when you're cutting calories. You got to do it progressively. You got to do it slowly. Like the first thing that you could do right off the bat is calculate your basal metabolic rate. Just figure out, all right, how many calories does my body burn in general? And then just make sure you don't eat more than that. For a lot of people, especially if you are gaining weight, what that means is you are eating more than your body is burning off. So the first goal could be, I'm just going to stay at this basal metabolic rate. I'm not going to go above it. Then the second thing you could do is take that number and subtract 300 from it. Because what'll happen is after about 10 days of eating 300 calories less, that means if your body is burning, let's say 2,300 calories, and you only eat 2,000 calories, That means every day your body is burning an extra 300 calories than you're taking in. So when you decrease it subtly like that by just 300, after 10 days, that's 3,000 calories, which is almost an entire pound's worth of fat in just calories that your body's burning off just to stay alive. We're not even counting calories burned by exercising. So if you were to burn 300 calories while exercising, that's an additional 300 on top of the 300 that you cut out with the eating. So now you're looking at 600 calories. And after 10 days, that's 6,000 calories, which is well over a pound's fat in terms of like how many calories a pound of fat is worth. So hopefully this video provides some insight, gave you a little bit of science background there with the rocket and stuff like that. And if you guys got any questions, comment below and make sure to hit the subscribe button if you thought this was helpful. Thanks so much for watching. I look forward to seeing you in the next video. Peace.